Yo, what's up everyone? Welcome to Electrochemistry Part 1. Today we're going to be talking about redox reactions. And redox reactions are the fundamental basis for a branch of chemistry known as electrochemistry. Electrochemistry is the study of the relationship between chemical reactions and electricity. So what we're really looking at is a transfer of electrons. Electricity is defined as a flow of electrons, and we'll look more into that a bit later. But electrochemistry just deals with chemical reactions where a transfer of electrons is involved. And the type of reactions characterized by a transfer of electrons are called redox reactions. And so let's take a look at a really simple redox reaction. In this case, we have iron 2 plus and cesium 4 plus turning into iron 3 plus and cesium 3 plus. Now the thing with the redox reaction is that it's characterized by a transfer of electrons. So a species must lose electrons and a species must gain electrons. So we can take a redox reaction and split it up into two different half reactions. One of them is going to involve giving off an electron, and the other one is going to involve taking in an electron. So let's look at that first one, which is giving off an electron. You can see that iron is going from 2 plus to 3 plus. And so if you look at this half reaction here, the charges aren't really balanced. The charge on the left hand side is 2 plus and the charge on the right hand side is 3 plus. So what's going on? Well, what's happening is that the iron 2 plus is giving off an electron to produce that iron 3 plus. And so this half reaction, this is one of the half reactions, this half reaction is known as the oxidation half reaction. In the oxidation half reaction, electrons here are produced, and this is going to be half of a redox reaction. So iron is going from 2 plus to 3 plus, so oxidation reactions involve the charge increasing. On the other hand, you have cesium 4 plus going to cesium 3 plus, and the charges still aren't balanced, so you have to figure out which side to add the electron to in order to balance out charges, and instead of the product side, it goes on the reactant side this time. So the cesium 4 plus reacts with the electron to produce cesium 3 plus. And this half reaction is known as the reduction half reaction. It's known as reduction because the charge decreases because you're adding an electron. And so a redox reaction is characterized by an oxidation and a reduction half reaction. And you might be wondering which one happens first. Does oxidation happen and then reduction, or how does it work? Well, in a redox reaction, the oxidation and the reduction reactions happen at the exact same time. So the transfer of electrons is instantaneous, and if you were to add up both of these half reactions, the oxidation and the reduction half reaction, you would get back the original reaction that you were dealing with. And so what's really just happening is that an electron from the iron 2 plus is going to the cesium 4 plus. And so when the electron from the iron 2 plus leaves, when iron 2 plus gives off an electron, it creates iron 3 plus, Fe3 plus, and then when cesium 4 plus takes in an electron, it loses, it reduces in charge to produce cesium 3 plus. And so that's really all that's happening. This is a really simple redox reaction where the iron is giving off an electron to the cesium. And the reason this unit is so helpful in just everyday life is because this unit is the basis for electricity. Electricity is just the flow of electrons. So if you have your iron and you have your cesium, you know that the electron is going to go from the iron to the cesium. So if you can extend the length that the electron has to go through, if you make it longer and longer, the electron has to flow through a much more space, and that flow of electrons is just electricity. You could put a light bulb here, I guess I'm doing this in the wrong color, and it would light up. That's electricity. So this unit has a lot of implications in the real world. This is electrochemistry. This is the study between chemical reactions and electricity. This is how batteries work and all these different types of electrochemical cells work, and we'll look at that in further videos. We'll look at galvanic cells, we'll look at electrolytic cells, and you'll see why your cell phone is rechargeable, why it works, how power is put back in the battery, all that stuff. So electricity or electrochemistry holds the secrets to all of that. But let's go back to introductory stuff. So the next bit I want to talk about is oxidation numbers. Now, if I gave you this reaction and I told you that it was a redox reaction, would you be able to tell me which species is being oxidized and which one is being reduced? In other words, is the magnesium losing electrons? Is the nitrogen losing electrons? What's happening? Which one's losing electrons? Which one's gaining electrons? In order to figure that out, we need to look at something known as the oxidation number. The oxidation number is the hypothetical charge of an atom if it were bonded ionically. Now, a lot of compounds are not bonded ionically. In fact, no compounds are purely ionically bonded. But if you were looking at the hypothetical charge of the atom, what would the charge be? If you were to look at a compound that's bonded covalently, and you were to just splice off the electrons, what charge would that atom have? And there's a couple rules that govern oxidation numbers, and they are here. So uncombined elements have an oxidation number of 0. Group 1 elements have an oxidation number of +1. Group 2 elements have an oxidation number of +2. What this essentially means is that if you were to take the hypothetical charge of the atom, if you were to kind of split it off, even though it's bonded covalently or whatever, if you were to just split it off, that atom on its own would have a +1 charge. And group 2 elements would have a +2 charge. Hydrogen has an oxidation number of +1 in non-metal compounds and -1 in metal compounds. Fluorine is -1, oxygen is -2. It has some exceptions, whoops. Chlorine is -1, actually let me erase that. Chlorine is -1, a monatomic ion and polyatomic ions. All ions, the oxidation number of that ion is just going to be the charge of that ion. And so let's take these rules and apply it to our problem here. So I'm going to write the equation again without the stoichiometric coefficients. So you have magnesium and nitrogen reacting to produce magnesium nitride. And so what's the oxidation number of the magnesium? What's the oxidation number of the nitrogen? Well, magnesium here is an uncombined element, so its oxidation number would be 0. The nitrogen here is also an uncombined element, so it also has an oxidation number of 0. Now things get more interesting over here. We have magnesium nitride, and so we have to figure out what the charges of the magnesium and the nitride are. Now magnesium is a group 2 element, so its oxidation number is +2, and there are no really rules for nitrogen, so you have to figure out what the charge is based on the charge you have here, and knowing that the entire charge of the compound is 0. So magnesium 3 N2, magnesium nitride has an overall charge of 0. We know that each of the magnesium atoms have a charge of +2, so 3 times +2 plus 2 of whatever the charge of the nitrogen is has to equal 0. The sum of all the charges must equal 0. And so what is the charge of the nitrogen? What is x? Well, if you just solve for it, x is -3. So magnesium goes from having a charge of 0 to a charge of +2, and nitrogen goes from having a charge of 0 to a charge of -3. So reduction involves reducing the charge. Nitrogen is getting reduced. So N2 is reduced. It goes from 0 to -3, and then magnesium is oxidized. I don't know if I spelled that right. Oxidized, I think. I don't know. So 0 to +2. So nitrogen is reduced and magnesium is oxidized. I feel like that looks wrong, but I think it's right. And so oxidation numbers are really helpful. They help you know which species is being oxidized, which one is being reduced, and that will help you in the future when we look at more electrochemistry. But today is just a basic introduction into electrochemistry. We looked at redox reactions, which are the fundamental building blocks of all of electrochemistry, and we looked a little into oxidation numbers. I hope this was helpful. I hope you were able to learn something. Please consider leaving a like and subscribing, and I hope to see you later. Thank you.